Hello students, welcome to my channel PC Geo Kimberlite, a source of diamond. Today we are taking a topic from stratigraphy, process controlling stratification. I am Dr. Sajid Hundekar, Associate Professor and Head, Department of Geology, AKI, Spooner College of Arts, Science and Commerce, Camp Pune, Maharashtra, India. It is affiliated to Savitribai Phule Pune University, that is SPPU Pune, and formerly it is known as University of Pune. Stratigraphy, yes, the word. Already we have uploaded various videos on stratigraphy. Those who are interested, they can go to my channel PC Geo Kimberlite, a source of diamond, and there you can see in the category stratigraphy, you will find out various videos which are uploaded on the stratigraphy. And this video we have been totally devoted for the processes controlling stratification. So we'll see first the simple definition about the stratigraphy. So we'll just have a revision. Strati means layering and graphy means the parameters, where we can study the study of that particular strata with different parameters, where we can study the vertical succession, horizontal succession in sequence with fossil content and the correlation. When you make these study of that particular strata with these parameters, then that branch will be called as stratigraphy. And stratigraphy is the backbone of the geology. And how these stratification, what is that stratification? Is the layering. It is the non-genetic term which will be given for only layering of rocks. That is normally the sedimentary rock, and which have been these sedimentary rocks which have been formed in the normal geological processes. And these stratification will be controlled by three important types. First one by physically, second one chemically, and third one biological one. So we will first see physical. It will be called as the mechanical one. The second one is called as chemical one, a biological one. And in your, if it is offline, your exam is there, so there you can expect that this question will be asked for a long question. Describe the various processes controlling stratification. If it is not there, then anyone will be there for write a short note for 5 marks. Physically controlled stratification, or write a note on chemical controlled stratification or biological controlled stratification. Now, might be we are thinking that this year again we will have to go for the online MCQs. So you have to be prepared this topic thoroughly for the stratigraphy. In the next what we have the semester, but not this semester, we have been going to face that problem. First we'll see how this sedimentary rock, layering rock have been formed. First one, whatever the pre-existing rock, whether it is primary, secondary or tertiary. So primary rock is igneous rock which is exposed to the atmosphere. So once it is exposed to atmosphere, various geological agents will act on this particular rock and the weathering will be started. What is that weathering? Whether mechanical weathering, whether it will be a chemical weathering. Once a chemical weathering is there done, that's the hard rock is there. Say a few centimeter rock has been weathered, then that will be going to give you the soil. So soil is nothing but the weathered product of the rock. So now there will be a breakdown, mechanical breakdown has taken place, and if the water can come in contact with that material, whichever the finer material is there and that NaCl is there, they will dissolve, and depending upon the altitude and what will be the position of that particular sedimentary rock, where it has been, where these rocks are exposed and gone under the weathering, mechanical weathering, then there will be chemical weathering, there will be a transportation. After the transportation, during the transportation, there will be attrition, abrasion, collision. So these things are there, wearing, tearing continuously taking place till it deposits. So transportation is there. In that transportation, one cycle, second cycle, if there is there, then that will be called as a denudation, erosion, denudation. If erosion is there, whatever the material which is there with eroded, it has completely transported with the help of the whatever the geological agents are there, like a surface water is there, or whether wind is there, glacier is there. So these are the agents. These are the agents which are carrying the material from one place to other. So erosion, and if this erosion is taking place in a cycle, then that is called as a denudation. So transportation is there. After the transportation, wherever we get a depression, in that depression the material will be dumped, and as soon as the water becomes stagnant, water will be evaporated. Now whatever the material which are coarser, first they settle down, then the finer, ultimately those material which is dissolved into the water, it will be precipitated and settle down. So whatever the material which is carried by the wind or water, they will be divided into bed load, which is a very heavy one. Just their rolling, traction and saltation has been taken place. Bottom we have that part. So bed load we call. Second one, those material which are the finer one, they will be suspended in the water itself. So suspended load. And the third one, whichever the material which is dissolved in the water, that is the dissolved load, that is called as the. So we have the bed load, suspended load and dissolved load. So these are going to dump it out, and with this we are going to get the continuous deposition. So if the erosion is continuous, transportation is continuous, and automatically deposition is continuous, then the layering will be going, we are going to get the perfect one. So there is no chance for the erosion wherever the material is dumped. But in case if there is no erosion is there, then automatically no transportation, no deposition. So that material will be exposed, and from there again the erosion may take place. So wherever deposition is 100%, layering is perfect. Wherever there is a less deposition and erosion is there, then there we are going to get the various unconformities, local unconformities we are going to make. So the deposition is there. After the deposition, accumulation which has taken place, water will be evaporated on all the cemented material, whatever we have. Now whatever the broken material, whatever the primary rocks are there, primary rock which is we have, igneous rock has been broken down, where it is crystals are there, minerals are there. If mineral is broken into the pieces, we don't call it as a mineral, we call it as a grain, sediment, particle. Once these sediments, particle which have been transported, deposited, and at the time of deposition water is evaporated, they are cemented with the cementing material, and due to this the compaction has taken place, and this compaction is led by the cementing material, and ultimately we are going to get the complete secondary rock, that is the sedimentary, and all these processes which we are going to take place, it is in the normal environment. If anything has been deposited at the time of deposition, there will be the variation added over there, and the colors we are going to get into the sediment. We are going to get grey color, black color, green color, yellow color. So varieties of the color you are going to get in the sedimentary rock, and that's why in the sedimentary rock we are going to get the fossils. In igneous and metamorphic we don't have the fossils, but fossils maximum they will be found in the sedimentary rock. So here we are again describe the rock, igneous, metamorphic or sedimentary, exposed to the atmosphere, weathering takes place, mechanical or chemical, then the sediments have been formed, whether they may be a very coarse, cobble, pebble, gravel, they are there, then the medium sand, then coarse sand, medium sand, fine sand, then silt, clay, and what we have iron. So these are the smaller one. The greater one size on the top, as you go bottom, finer and finer. Then these sediments will be transported with the help of the geological agents, whether they may be wind, the flowing water, then we have the glaciers, and sorting will be taken place, rounding has taken place, where attrition, abrasion, collision which has been taken place during the transportation. After that they will be deposited in layer, then compaction and cementation, silica, calcite, hematite, and we are going to get the rock, whether it may be a sedimentary rock, conglomerate, breccia, where the sandstone, varieties of sandstones are there, then we have limestone, shale. Yes, so these are the varieties of the rock. By this process we are going to get the rock. Yes, here this is a very, very important picture. I will just discuss and then we'll go for that process. So here, this is the first one. Any rock at the surface which has gone under mechanical weathering, it is gone under chemical weathering. Now after this mechanical weathering, there is a break into this. They are going to get the sediments, which they are the sediment particles will be there, and they are, once they are there, they are called as plastic sediments, because we are going to see with the own eye, mechanical breakdown has taken place, no chemical reaction has taken place. So they have the intact, if you see that particular particle sediment, we can say that it is coming from which particular part, whether it is coming from granite, whether it is coming from any metamorphic rock, that will be make out, and in that we are going to get sand, gravel, seed, mudstone, all will be there in that particular clastic one. And in that chemical one can break into the dissolved ions. So chemical water come in contact, the Na, Ca, K, Al will be dissolved. So we are going to get the dissolved ion, and in that second one can create the clay. If the fine sediments which will be there, that will be a montmorillonite will be normally we are going to get in that our Maharashtra territory. There will be a various modes will be there, and dissolved iron will going to give you the erosion. Then after the erosion, again the stream, groundwater, it will carry that material to the ocean. Whatever the material which is dumped, they will be transported, and they will going to dump into the ultimately into the ocean part. Come to this particular part where we have the clastic. In that clastic sediment, plant will grow, and these plants, what we have, they will be going to deposited, whatever the sediment which are broken, they will be hold properly, or there might be, there will be a swamps maybe taken place, or the whatever the dissolved iron crystallize, say from ocean, that is crystallization process. Due to this, the organism like what we have, the corals, from where the calcium is going to deposit, create the mineral, whatever the minerals which are there. Once the crystallization has taken place, minerals will be deposited. Then there will be sediments will be hardened and becomes the lithified, and from there chemical sedimentary rock has been formed, and burial composition, cementing material, all these are going to make into that lithification. So that part will be there. So deposited, lithifying and lignite and pass. If that particular plant has been deposited in the sediments, then we are going to get lithified, and slowly it will be converted into the peat, lignite, such type of coal which will be going to form. In the classic sediment, if it is erosion is there, then there will be stream waves, glaciers, gravity, wind, that will be the agents will be act on that for the erosion. Then after the erosion, next one is deposition. After the deposition, there is a lithification, and in that lithification we have burial compaction and cementation. And due to this plastic sedimentary rock, here we have non-classic sedimentary, that we called as non-classic. Classic sediment, this is the way the whole sedimentary rock which has been formed, and what are the processes which are involved. It has been shown with a small chart, and now we'll just start the process controlling stratification. And in that, the first one, factor controlling physical, yes, physical factors. Now these are called as physical or mechanical one. These factors control stratification in coordination with chemical and biology. It will be always associated, not only one physical is doing, but in the nature every process is going in hand. So the physical, it will be supported by the chemical, then there will be biological factor, so they are been there. So the physical or mechanical factor will be going to give you the control on stratification. One, non-uniform deposits. Due to this, there will be a control is there. We are not going to get uniform deposit, thick uniform. There will be always, because of that process, erosion process, weathering process, non-uniform deposit. Disturbance of sediments after deposition means sediment is deposited, but there is no excess deposition is there, but there is the erosion. So disturbance has been taken place. Again, from that, whatever the material which is deposited, from there it has been transported. Then stratification as a result of compaction of fine-grained sediment. So those sediments which are dissolved as a load, once they are great precipitated and settle down, at that particular point, the water will be a totally stagnant, and they are going to give you a stratification. Compact stratification grain will be formed. So we'll see one by one in that. First one, non-uniform. Why we going to get the non-uniform deposits? What are the types are there? Which point will be going to control that particular part, or that will be reserved either from where? First one, why we can get the non-uniform deposits? Why we could not get a uniform? Say example, uniform deposit means in a class 4 standard. So all 4 standard students which are sitting in a class, they have one uniform. Yes. a blue, say example, a blue shirt is there and grey pant. This is one dress. So everyone is wearing that dress. So that class will having whatever the students which are sitting, that is the uniform one, proper one. But in that somebody is wearing red shirt and t-shirt and sit over there, then that is the odd one. So here in this stratification, such things are happening. Non-uniform deposits we are going to get. Why these are happening? Because of the change in the type of material deposit. For example, whatever the supply which is coming, whatever the water is coming, this is coming from this end. Say north end is coming, water is coming, and in that north area, the granite is exposed. So granite is weathered, material is coming from that north side. But after some years, there is no weathering of that particular part. Favorable, what will have condition is not there for expo or that the granite is weathered. But we are going to get it from the western side. There is a sandstone is there, and that sandstone has gone under weathering. And from that side now, the material is coming and it is dumping out. So there will be a non-uniform material is deposited. Earlier one, the material is coming from granite terrain. Now the material is coming from the sandstone terrain. So due to that, there is not having a homogeneity. We have inhomogeneity has been formed. Change in the type of material which is deposited. Now why this is there? I told you that different source will be there, and there is what are the factors which are going to control. And due to changes in the rate of deposition, for example, the rate of deposition, every year there is a say deposition is there about 5 centimeter material will be deposited in one season. But there is a fluctuation is there. This year, say 2020, 5 centimeter material is deposited. 2021, it is only 4 centimeter. Now in 2022, again 7 centimeters. So variation is there. That means every year there will be conditions are changing on the surface, and due to that whatever the source rock which is exposed, depending upon its what is the composition is there, what are the agents acting on that, what will be its elevation, that all points we are going to see in detail. So that are the very important one. But the first two important one is the material which is deposited. What type of material is deposited? That is coming from granite terrain or it is coming from the sandstone terrain. So whatever, whether what we have, the aluminum is deposited or calcium material deposited or sand deposited, whatever the material which is deposited, that the change in the type of material is deposited due to changes in the rate of deposition. And now we will see why the changes will be there in the material deposits. Factor affecting quantity and quality of the sediments. I told you that is the granite as one side we have, north side we have the granite, and what we have, the western side we have the sandstone. So these rock has to be exposed and they have to go on under the weathering. Everywhere the weathering will not similar one. So how much quantity it has gone under the weathering and how much quantity quality has gone and how much quantity has been produced, and from that particular point how much material has been carried by the running water or wind and they are dumped into that particular basin. So that will be going to affect the quality and quantity of the sediments. Second factor, the factor affecting transportation. Once the quantity is available, now the transportation media, whether wind is there, water is there, which source is there, every time if it is going to change, that is going to affect that particular part to carry that sediment from this particular to this level. Local factor determination of accumulation. If you want to have the accumulation at that particular point of the depression or the whatever we have the basin is there, in that if we don't have the local factors which are going to affect. So we'll see what is in detail about that particular part. So in that, the first one, formation of detrital material is mainly depend upon, if you want a detrital material, the material which has gone under erosion. Yes, it has going under erosion, the climate, topography, that is going to play important for this particular, for favorable erosion. If you want a favorable erosion, maximum erosion is there, then what is required? The climate has to be suitable for the weathering one. The second one, topography, that particular area should be in a high hilly areas. There should be heavy rainfall. So if it is there, then that will be, source will be easily available for maximum material which will be available, mechanical weathering as well as chemical weathering may take place for that particular change in the uniformity of the deposits. So hence we have the granite and basalt give rise to a different type of detrital grains. Similar one, granite, sandstone or conglomerate, whichever we are going to make out limestone. So that here the best one is, we are living in Pune, Maharashtra, where we have the basalt is there. So we have taken a basalt as example. So equivalent to the basalt, which is the representative is granite, acidic magma, and the basalt is the basic magma. So these two rocks we are taken into the account. Now you can see what is the composition of the granite and basalt. Everyone know this is already have been studied in the hand specimen. The granite, it is showing you equigranular texture. Coarse grains are there. It is a light color because of there the silica percentage is more, and due to that what we are going to get? We are going to get the quartz, feldspar. These are the dominating method, and in that feldspar we are going to get whether plagioclase or orthoclase. If the plagioclase is there, the grey granite is there. If the orthoclase is there, pink granite is there. Then hornblende, it is a dark green. Then we have the biotite, it is a pearly and black in color. Then muscovite, light yellow, and pearly luster. So these are the important minerals which are been present in the granite. Whether they may be fine to the dark color, all these material will be there, which have been minerals are there. And if the condition, climatic condition which are there, they are going to play a vital role. If these rocks are very hard and tough, and if you want to break them, we require a suitable climatic condition. When the basalt undergo erosion in a monsoon type of climate, then there is a result into the laterite, because there what happened, the whatever Na, Ca, K and alumina, they will dissolve in the water and carried out. And so those who are there in Pune living nearby, we know basalt is there. But from here, if you go to the Mahabaleshwar area where we have the tableland, yes, the Panchgani, we have a tableland is there. In that tableland, what we have, it is a flat table is there. And that what we have the mesa which is there, it is made up of the laterite. So what is happening? In that earlier one there is no laterite, there is a basalt, but there is a heavy rainfall is there, and in that rainfall whatever the basalt cracks are there, these cracks are filled by the water. There is a chemical reaction, whichever the plagioclase mineral is there, it is dissolved NaCl, and automatically whatever the remaining element which is there, the iron is go on increasing, the percentage of the iron go on increasing. If whatever the shape of that particular plagioclase is there, once it is dissolved, a cavity has been formed. So there we are going to get the vermicular structure of that particular laterite, and due to the iron rich is there, it has become the red buff color. So that is the indication that it is due to the climatic condition which are favorable for the weathering. Therefore, when basalt undergo in the monsoon that we have been seen, that laterite will going to form in that particular tract and result into the more calcium which will be there in the water of the material which is going to do. Next one, elevation. We are going to make out the topography. In that, if that particular Mahabaleshwar is on the ground, mean sea level, then there is whatever the erosion which may take place, it is a less, and the material which is transported from that particular part will be a less. But now what happened, the whatever the Mahabaleshwar is there, it is a hill station, it is from the mean sea level, it is at the top and maximum erosion taken place, and there due to this elevation, if any push has there for the grain comes down drastically, rolling down, and there is a erosion has to be taken place. So sediments are with less pressure, they are eroded very easy. So there will be water playing a vital role in the transportation media. And during the upliftment of the Himalaya mountain, the coarse sandstone were produced when steep slopes were developed and shells were deposited during the contour period and gentle slopes. So these are the depending upon the elevation. Next one, the kind of transportation. Which particular medium is there for the transportation is there, and that is a very important one. Then what type of media is there, whether it is a wind is there, surface water is there, or glacier is there, and what will be the effectiveness, what will be the velocity is there. In the rainy season, if you find out these rivers which are coming out from what we have the Mahabaleshwar, will find out they are having contained a very high speed because they are at a high altitudes are there, and from there whatever the water is flowing, we are going to see the many waterfalls which are there in that particular area. So effective transportation is the water is the media, the path is there, and the direction of flow is there towards the normal, towards the sea. So that is there that particular part. So this is what we have, the important one. What type of transportation is there? What will be the effectiveness of the transportation? What will be the velocity? If the velocity is more, then automatically quantity which is carrying will be more. If it is less velocity, less will be the quantity will be there. And depending upon from higher altitude to the low altitude, the water will be transported. So this is the way, these are the kind of transportation. For example, during the Pleistocene, the glacial deposits are stratified because of alternate deposition of glacial tilt and wind blown loess. This has been found during the Pleistocene glacial deposits. That has been given an example. Similarly, glacial varves. What is a varves? In one particular season, whatever the material which is deposited is called as a varve. They are very thin layers are there. What is the varves? Have coarse and fine grained layers proportional to the kind of transporting agents in the glaciers. Coarse grained layer are deposited during the transport of melted glaciers. Now, with the coarse grain, we can immediately indicate that these material which is deposited, they are during the transported by the melting glaciers, while fine grained sediments are developed during the interglacial periods. So this is what we have. We can make the results from this particular grain size. Any change in the power, yes, how much is the velocity of that particular transportation agents are there, and depending upon the capacity will be going to play a very important one. If say I have a fully charged, so I can carry 20 kg load. But if I say my age is 60 now, if somebody is there of a 40 age, he can carry 30 kg. If somebody is there of 20, so he will having a lot of energy, so he can carry 50, 60. So that much there, depending upon how much is the energy of that agent is there. That with that force, with that velocity, whatever the material which is carried with them, it will be best that the quantity, whether coarse grain or fine grain will be. If the velocity is low, only fine grain will deposit. When speed is very high, at that time coarse as well as fine sediments will be transported, and that will be speed is large, then they travel longer distance. Speed is very short is there, slow speed is there. So 20 kilometer per hour is there, then that is not there. But if 100 kilometer speed is there, then we will find out in the flooding of wherever the floods are happening in India. Now we have been seen in the last month itself in Tamil Nadu, Andhra, Karnataka, we have the floods. We have seen if the floods are there, whatever the two-wheelers, four-wheelers are there, they are also carry with them with that speed of that particular water, and a lot of casualties that are happening due to this particular agent because of their speed is very high and the volume is also a large one. This will give rise to stratification as seen in floodplain and delta. This is going to see the best example is floodplain and deltas. In the floodplain, whatever the channel is there, the water, excess water will be poured off the side, and due to that, whatever the carrying material is there, it will be dumped into the surrounding vicinity. So that become the floodplains. Deltas, Sundarban is the best example where we have in the West Bengal, where whatever the river, Hooghly river is there, and it is continuously depositing the material. That is the Brahmaputra has carrying the material. That is all are the alluvium is there, and that deposited, and the road is been blocked due to the dumping, and now it will cut down, and we are going to get the deltas which have been formed. So Sundarban is a best example for the Indian students. The changes in the direction of transport, that is also play a vital role. Say example, the river is running now, like what we have the Kosi river. It has totally changed its course. 400 kilometers shift. Has been taken place during the flood. So that may happen that continuously dumping is there, and due to that changes the direction that has been taken place. Changes in the direction of the transport bring about the variation of the deposited material. So that also play a very, very important part, and this may control the volume of the sediment which have been deposited in the particular area. The transporting stream, currents, waves show a large changes in the short time period give rise to a non-uniform deposits. Now here we have shown you the what with the material which is there. It is a fine grain. Immediately on the top we have the different material which will be deposited. Local factor determining the accumulation of sediment in an area include depth of the water. How much is that particular depth is there in the basin? If the depth is more material will be deposited. If the less is there, less will be deposited, and whatever the material which is deposited will also carry from that, because it is shallow depth is there, and with the speed, whatever the material earlier it is deposited, it is carried. At the time of erosion as well as transportation will take place in the where the depth of that particular basin is less. But if the depth is more, then there is a chance to get more deposits, and there is a less erosion is there as compared to what we have the basin where the depth is very low. So depth is also going to play a vital role in the local factor which will going to make out related to the wave action, and that going to control the deposition in the sea as well as on the other water basins. The wave base or the depth at which the waves are unable to affect the sediments is a very critical level regard to the sediment deposition. Wave base does not correspond to any depth because the wave turbulence decreases towards the downwards and loses its effectiveness in moving even the smallest particle. Yes, the depth is more, then ultimately it is not going to make any effect in the at the bottom, but those depth is very less, so on that surface whatever the material which is deposited, it is immediately eroded from that particular part. So that place, the whatever the depth part is there, that is the wave base or the depth of that particular ocean surface water or wind, that play a vital role. However, the depth of the water may change due to the tectonics, sea level changes. So anything will be there, the tectonism which will be going to affect the depth of the water. Similarly, nowadays what is happening in Pune also, whatever we have, the rivers are there, Mula and Motha, which are running from the center part of Pune, and what is happening last 15-20 years, lot of plastic we are going to use, and all plastics are dumped into that river. At the same time, whatever your building throwing material is there, it is dumped into the ocean. So ultimately what is happening? The base of the what we have, the rivers are completely packed with the plastics, and there is the overburden is there of that particular building material, and due to that if excess water comes out, there is no percolation, penetration is not there, so recharge is not there. So ultimately the depth of that water is river is go on reducing. If excess rains comes out, then there will be a flood like a situation is there in Pune, whether it may be what we have the main place Shivaji Nagar or the near whatever the banks of that particular Mula and Mudha, there will be threat has been taken place in Pune. Earlier one, there is no chance for the floods. Whatever the flood has been happened, which is the 1962, when there is the Panshet Dam has been broke its wall, and we have the flood in Pune. So we are a more stable part where we are not going to have such a like a threat, but now hereafter Pune also be coming in the threat because of we are using the plastic. Might be again next 15-20 years if we use the plastic, that will be vulnerable for these particular areas in Pune. We are going to hit that particular situation like a flood. If basin becomes shallow, if bottom gets eroded, yes, if it is shallow, it is eroded, and if the basin deepens, then greater deposition tries to bring the bottom up to its previous level. Yes, if the depth is go on increasing, then automatically there will be more chance to get the deposit. If it is depleting, the depth of that river or whatever the basin is there, it is go on decreasing, then there will be more chances for the erosion as compared to the deposition part. Therefore, variation in supply, that is important. Whatever the quantity and quality which has been brought by that particular agents, that is the transportation media, and the deposition location, how that depression is there, basin is there. So on these particular nature, the development of stratigraphy is based on. Come to the next B part, that is the disturbance of sediments after deposition. Why there is a disturbance is there once the material is deposited? There are the number of factors are there. First one, the rolling of bottom sediments and settling down. Say river is flowing now, water is in the high recharge, speed is very high. So at that particular point, the very huge pebbles, bubbles are there. They have been traction is there, rolling is there. Due to that rolling, they hit and again jump, hit and jump. Traction saltation has taken place, and due to this, whatever the material which is deposited, they are again eroded. Erosion has taken place, and that material also with that particular speed they carried out. So that is the one case where if the whatever the speed of the agents are there, they are increased, and at that time the huge boulders are been rolling, traction and saltation has taken place, and due to that, the whatever the bed material which is deposited just now, it is also eroded and it will be carried out. So due to that erosion of that particular sediments, this is the second part. One of the two processes usually dominate over the other. So this will be always get together, they will be there, and due to that the domination may take place. The rolling of the bottom sediments followed by settling at the same place. Sometimes what is happening? Now jumping traction speed is there, but after that the next maybe in situation the velocity of that particular water is decreased. Immediately the dumping will be start. So that will be there. So here that dumping, the deposition which will be taken place, that will be based on the degree to the bottom of the sediments disturbed by the action of waves. So here, what is the depth of the basin? That is very important one. Shallow or a greater is there. What is the size and coarseness of the particle? Very huge boulders are there, very fine or suspended particle is there. That is a very important one about the size of the particles. And the third one, what is the size of the waves? Whatever the river or surface water is flowing, what will be the waves are there? If the waves are large in size, there will be more erosion, and if they are less in the size, then there will be less, and there will be a deposition. If the tide just they flow with the normal speed, then there will be a chance to have the deposition instead of the erosion. So these are the three important things: depth of the basin, size or coarseness of the particles, and the size of the wave. That way is going to play a vital role. The water basin, waves should be much more effective in bringing about the turbulence of the sediment. Where the shallow water basins are there, waves which are there, they are effective in bringing about the turbulence of the sediments. Rolling will be there, and the coarseness of the sediment affect the degree of turbulence. Effects, extent, and the disturbance of experienced by the sediments is related to the size of the sediment particle. The finer are more easily displaced than the coarse one. Yes, for example, there are the one is 100 kg, we have a load is there, bag is there, and there is a 20 kg bag, and just push with your hand to 100 kg. It will not push from that surface. It requires more force to shift it from one place to another, but the 20 kg, just if you push it out, it will shift it out, because that force you apply with that, whatever the size and the shape is there, whatever the weight is there, that will be rolled out. The smaller one will be easily rolled it out as compared to what we have the heavier one. So the coarseness, once the coarseness is there, the gravity will be more and require more turbulence to change their position. Otherwise, that will not be going to have the experience. So extent of disturbance experienced by the sediments on the basis of their related size of the particle, finer will be more easily displaced as compared to the coarse one. Then the size of the waves, that is a very important one. Very big is there, it's more great. I told you, if it's a bigger, I'm pushing with a more speed than 100 kg as well as 20 kg. 20 kg will travel a longer distance as compared to 100. But whatever I've given the energy, with that energy, both are travel with the same speed. But what is happening? Once that speed is gone decreasing, first settle down will be the coarser one, then the finer one. So once the velocity is gone decreasing of that particular wave, then ultimately for the first coarser material will be settled down, then the finer material will be. But those material which is suspended or dissolved in the water, they carry it a very long distance until that particular water has settled down. Then only whatever the material suspended, they settle down and give you a good deposits of stratification. Then the finer material will precipitate and settle down. These are what we have the factors. So graded bedding, this is the best example. The coarser material will first settle down, then the finer, then the finer, then the finer. Ultimately, once it becomes, the water will be stagnant. The material which is dissolved, it will be precipitated. So that gives you the gradation. From the top, it is a fine grain that indicates the younger rock which is deposited, and if you go down, you are going to go towards the older and older. That is the graded bedding is there. The velocity is decrease of that particular agent which carrying that material. Immediately, what is happening? The sediment will start settle down. Coarser will be first side, and that what are the three important things? What is the size? What will density and what will shape? If rounded is there, it will be more rolling. If the square is there, it will settle down. Angular is there, it will be settled down. But the rounded one will travel along. But if it is a heavier one, then it is a very less, it will be transported. So size, density and the shape are going to play a vital role at the time of the wave which have been carrying them. Of the deposited material, whatever the material which is deposited now as whatever the water or whatever the agent is there, the speed is increased, then whatever the material which is earlier deposited, it will remove from that place and it is transported to some other place. So the erosion will be taken, destruction will be there of that particular part. So erosion may bring down the destruction and the removal of sediment from that particular part, and it is carried somewhere else. So that is the erosion of the deposited material that takes place because of there is the high velocity of winds or waves are come out, and whatever the material which is just dumped out, they will be carried out. Next one, compaction of the fine grain sediment. Once the material will be settled down and water has been evaporated, then whatever the fine grain material is there, it is going to cemented to that cementing material to that particular sediments and particle, and there will be a compaction. Stratification has been compacted material will be there, and that is going to give you the stratification. So that will be going to show the shale rock will going to form. The second important one, chemical factor. The chemical deposits which are there, that is whatever the water is coming in contact with the fine grain, there will be first whatever the chemical reaction has taken place between the water and the weathered material, and in that Na, Ca, K, Al, they are easily soluble in the water, and that water becomes the organic water. So change of the conditions of that water, so that water becomes the physico-chemically organic water has been formed, and that water carry from one place to other, gives rise to the stratification. Once the water becomes stagnant into the basin, and whatever the material which is deposited will get precipitated, and there will be reaction has taken place and material will be settled down. That is the limestone chemical deposit, and that will be alteration has been taking place. The original composition of from where that material has brought, we could not trace that from where it has come out. It is completely chemically altered, and that's why it is called as chemical deposits. And now these stratified chemical deposits result due to what? Right. So whatever the water is there, and in that water whatever the salt or whatever the element which are dissolved, and once the water has been evaporated, whatever the material which is deposited, they will be deposited into that cavity. Products of oxidation and reduction. If it is oxidation process is there or reduction. Example, if you put a rod or iron rod into water and bring it outside, then what's happening? We'll find the iron rod has been rusted. That is the oxidation has taken place. There is similar one, reduction process also there. So they are going to give you the chemical factors. The dolomitization. CaCO3 is replaced by Mg. So MgCO3 will be formed. So whatever the limestone is there, we are going to get dolomitic limestone. So it is called as dolomitization. As an effect of the interstratal solution. whatever the solution which are cracks which are there within the limestone or any rock which is there, in that water is percolated and it is dissolved in that particular chemical composition, like a calcium is dissolved, and whatever the crack is there widen and caves are going to form in that vicinity where we have the limestone. So this is the effect of the interstitial solution. So first we'll see about the evaporites. These deposits contain common NaCl. Whatever we have, the oceans are there, the salt is there, and if that in that we are going to see run of Kutch, where we are going to get the salt is there. Why the salt? Because there is earlier we have the ocean water is there. That ocean water has been evaporated and now salt has been deposited. Similar one. Next middle is the gypsum. CaSO4, 4H2O, that is the gypsum, and anhydrite. So these are the evaporite deposits. So name indicates that there is a evaporation has been taken place. Depending upon what type of composition is there within that particular water, concentration of that brine, that is water dissolved salt, and different minerals may be deposited, giving rise to layers, and therefore they are giving rise to the stratifications. If the water is almost agitated, then it may be give rise to a formation of oolites and a granular glauconatic material around the detrital particles. Products of oxidation and reduction. The environments of oxidation and reduction and their changes are important in the production, transportation, deposition and the alteration of organic and chemical deposits such as the iron compounds. So oxidation reduction has been related to the iron one. The presence of absence of organic matter in the Paleozoic and the younger sediment is intimately related to the oxidizing and reduction condition of the iron compound. So those in that area we are going to get these particular things. So for example, pyrite, siderite, these are suggesting reducing environment, while hematite, limonite suggesting the oxidizing condition. So remember these products which have been formed by the oxidation and the reduction process. Dolomitization, limestone get dolomitized when CaCO3 is replaced by Mg, then it will become MgCO3. Such dolomites are characterized by granular texture and brownish or greyish in color. The chemical changes also give rise to irregular pattern of originally layered nature of sediments, resulting in modified stratification, which is easily recognized. The effect of interstitial solutions in the form of dolomitization of porous calcite by magnesium-rich heavy brine moving through the pore space of the rock. Such percolation of concentrated solution gives rise to a variety of salts. Such a minor process contribute the development of stratification or formation of calcium concretions or sheared nodules. All these lead to the formation of pseudo stratification in the massive limestone. And the last one is the biological factors. Everyone knows there are the number of biological agents are there on the surface. Burrowing animal, that is the best one example. Man is also important. The agent is there who are making a lot of changes on the surface of the earth. So most calcareous sediments are the biological or organic origin. The quantity and the time of calcareous material deposited in the different strata is controlled by biological factors. Now what is that? Organic matter of the variable amounts in the sediments and the texture and color is helping differentiating them within the strata. Type plants and animal and their distribution is also affect the stratification. Presence or absence of foraminifera in the sediment is so sensitive to the minor changes in the temperature, pressure and other conditions of the sediment that may have been used to detection of oil reservoirs. So that is a very, very vital. We have the foraminifera and their presence or absence will give you the very, very sensitive indication for the changes in the temperature, pressure and the conditions at the time of the sedimentation. Some of the biological factors also associated with development of stratification is the abundance of life. and this is only have in the marine condition. On the terrestrial, we don't have that much conditions which are favorable for deposition, but once the animal or plant is there, immediately it will settle down, and there is a continuously deposition is there. So the composition and appearance of the sedimentary rock does not always indicate the abundance of organism which may have exhibited their formation. So in some area we don't find any fossil, but some area we have the very good fossils are there. So in that, in paleoclimatic condition or paleo, or maybe in a millions or billions year back, there is habitat is there, and due to that we are going to get the fossils, and that we are going to get the deposits which are taking place in that particular calcium deposits are taking place. Wherever we are going to have very high calcium deposits are there, in that area we say the marine climatic conditions are there, and there lot of plants and animals which are living, which are calcium one, like corals which are there, which will be a very important one for the formation of calcium deposits, which we are going to make out. The presence of calcium carbonate in organic matter will depend upon the following factors. First, abundance of organism. Yes, if the organism is there, in that organism, whatever the hard part, like mammals are there, we have the bones are, these bones where we have the calcium carbonate is there. So that will be a rich. The destruction, corals, they are the very important one. Destruction or shales, like molluscas are there, that will be enriched in calcium carbonate is there. Destruction and removal of organic matter and the rate of deposition of detrital sediments. These are the three abundantly going to affect the biological factors. Due to the fine-grained nature of sediment, the organic matter is well preserved in the shells. However, the coarse-grained sediment do not contain any organic matter because of their deposition is rapid and conditions are not favorable for the preservation of fossil. Then preamble nature of the coarse sediment causes organic matter to leach out, and interbreeding of limestone shale indicates either a fluctuating population of lime secreting organism or intermittent supply of the fine detrital sediments. And the last kind of life, so stratification is visible in the sedimentary rock due to variation of kind of life preserved. For example, organic limestone or coal we are going to get. Why these are there? Because of such type of life which is living in that past, and due to that, once they are dead, they are deposited, we are going to get the organic limestone, or whether we can get the coal deposits. Then the next one, the destructive of stratification. Why this is happening? The boring is there, and mud-eating organisms bring about searing and mixture of the sediments at the bottom of the basin, which destroys the stratification. With this, we have been completed the topic process controlling stratification. I hope if you have any doubts, you can write in the comment section. Now there are the 5,000 words are there, but the notes could not be fit into that 500 words. If anybody wants these notes, they can give me your mobile number so that I can share you on your WhatsApp number, or shortly we are going to upload this material on our Google site. Departmental Google site is there. On that we are going to put the videos as well as the notes. From there anyone can download that particular material. I hope this is clear. Thank you. Have a nice day.